Alright, in this video, I'm going to explain a little bit more about your upper and lower bound of the zero. So this is an example coming out of homework section 4.3. So for the upper bound, let's take a look. So when we do the P over Q right here, we know that the Q is 1, the P is 4, so that means my potential real zeros is going to be integers. So when we do the bounds for the upper bound, remember the last row of the synthetic division cannot be negative. The biggest issue, I believe, is what happened if it is a 0 here. Okay, so I'm going to try with the smallest integer, okay, which is positive 1. So let's check it out. You know what? I'm going to go back. I'm going to copy this real quick. I'm going to put it right here. So just in case you need to try another one. Alright. Smallest integer on the upper bound to the right hand side of the origin. Bring down the 1. 1 times 1 is 1. So this is a 0. So when 0 is right here, I cannot use it. Okay, because 0 under the lower bound count as positive, negative. I want all these to be positive. So let's try another integer 2. Bring down the 1. 2 times 1 is 2. Negative 1 plus 2, positive 1. 2 times 1 is 2. Negative 4 plus 2 is negative. So that doesn't really work right here because all my signs on this row got to be positive. So let's try another one. The next integer after 2 is 3. So bring down the 1. 1 times 3 is 3. Add them up is 2. This is 6. Add them up is 2. 3 times 2 is 6. Add them up is 10. So since the last row is all positive, then 3 can be my the smallest upper bound. What that means is I may have another integer after 3, maybe like a 4, maybe a 5, also gonna give me all positive coefficients. So this is the smallest upper bound I can have. Alright, so for the lower bound, the wording for the homework is the greatest lower bound. So I'm going one place to the left of the origin. So the first integer is negative 1. So if I bring it down, negative 1 times 1 is negative 1. If I add them up, it's negative 2. So for the lower bound, these signs got to alternate. Okay, 1 positive, 1 negative, and 0 count for positive or negative. Negative 1 times negative 2 is positive 2. Negative 4 plus 2 is negative 2. So the sign did not alternate right here. That tells me that this negative 1 cannot be my greatest lower bound. So now I'm going to try another integer, negative 2. The next smaller integer, the next one to the left of negative 1 is negative 2. If I multiply them, that's negative 2. This gives me negative 3. Negative 2 times negative 3 is positive 6. When I add them up, that will be a positive 2. Alright. So if I multiply here, that's going to give me a negative 4. If I add them up, that's a 0. 0 count as positive, negative. So positive, negative, positive, negative. So when the sign alternates, then that can be my greatest lower bound. Alright, so let's go back up here for a moment. The P over Q thing. The P is 4, so 1 times 4 and 2 times 2. The Q is 1. So when I list out my P over Q, it's going to be 1, 2, 4. I'm also going to have negative 1, negative 2, and negative 4. So without using a graphing calculator as an aid, the purpose of upper bound and lower bound is to eliminate the number of P over Q here that I need to try. So when we found 3 as the least upper bound. That means the one potentially I will try to find the zeros are 1 and 2. Potentially I will try it. So that means now I'm going to come back here and finish my problem, see if the remainders are 0. If they're not 0, then those are not my zeroth polynomial. As a matter of fact, 2 times -2 here will give me a -4. Add them up. So this is actually one of my zeros. Okay, if I will finish the problem. So we want to figure out a smallest upper bound. Okay, anybody below the integer 3 is the one I try. So for the greatest lower bound, okay, when I try -2, it turns out to be a 0. So my another potential 0 will be the next one I try is going to be what? -1. Okay, if I will finish a problem, I will find out -1 is not one of my 0. And that's the purpose of the bounds, is eliminating the number of the potential rational zeros that people have to try by trial and error methods. Alrighty, so I hope that will help clarify a little bit. Thank you for